Okay, Assalamu alaikum wa rahmatullah. Good afternoon for everyone. Today is our third class, inshallah, in the subject of SSK 3408, the database application development. And for today, inshallah, we are going to learn how to start the database design. Because in the first and second class, we already learned about the basics, fundamentals, and definitions of the database and database components and so on. So now we are ready to start the database design. The first thing we have to know about this class is the class objectives. So the objectives of this class is to let you able to describe the database design phases. So we will learn about the design phases, how many phases and what we do, what we have to do in every phase and so on. Then we will learn how to explain on how to construct the entity relationship diagram or ERD. And also we will learn how to transform from ERD to relation. Then the fourth objective is to know how to use the normalization to decompose a relation with anomalies into well-structured relations. So the first thing is to know the phases, then how to create the entity relationship diagrams, then how to transform the entity relationship to diagram to relations, to real relation. Then after that, we will use the normalization to make our design optimal. Okay, this is all about our class of today. Okay, in this slide we have some introduction. Okay, the goal of any information system is to add value for the user. So the importance of any database application or any information system is to give the value for the user or to add value for the user in terms of cost, reducing cost, or maybe increasing the speed of retrieving the data or following up with the procedures or whatever. And also it in terms of increasing the sales and revenue, and also in terms of providing competitive advantage. The need for database design is the flexible, the software is supposed to be, or the system supposed to be flexible enough to handle the future needs. So we have to consider any future possibility of procedures or of new features that could be attached to the system in future in order to make our system flexible enough to fit these future needs. And also the future developers to understand the system. We have to also write notations or comments about our design, about our fields, about our tables and everything, in order to allow the future developers to understand the system and see how to check the system or to maintain or to fix some bugs or so on. Then to communicate with users and IT staff. The important step of all methodologies is to build models of the system. So the methodology that we are going to use is all about to learn how to build the models of the system. So everything is related to the design actually in this class. Okay, database design, system design. So in this slide here we have four stages of designing the database. The first stage is to make some user views of data. So we have to go to the customer and we have to sit with them, with the company or the organization that we targeted for our system. Then we have to discuss with the people in charge to understand the procedures and how data is collected, how the data is processed, and what kind of report we are needed to produce, and so on. Then after we get the idea about the system from the users, then after that we will be able to start building our conceptual data model. So the conceptual data model, it will be a diagram like this, as you can see here in this slide, number 2. So the conceptual data model will include the class diagram that shows business entities, relationships, and rules. So here in this diagram, in this conceptual diagram, we will show that our system, for example, has some orders, has customer. The customer can make orders, and the order could have some order lines, and every order line will have one item, for example, and so on. And the item information is item name, price, and maybe expiry date, and so on. So it's something like this. But in here, in the conceptual data model, the details of the entities, for example, the item, the order, the customer, details about them is not needed here. So here only we need to use the what they call it, the entity names to there is some efficiency. Sorry, doctor, I can't hear clearly. Who can't hear clearly? I think my voice is very loud, right?
No,
No, doctor.
no, no.
Is it? It's not clear.
It's very
Loud,
slow.
little bit loud. Okay.
Now it's not very clear. Are you sure?
Now it's a little bit okay.
What's about this?
Okay, okay.
Now is okay.
Yes.
Okay. Okay. So here in this conceptual data model, the thing that we have to make is like this. For example, we have user like this, and maybe we have an order, and this user can make an order. Maybe we draw a relation like this. Then the order could have, for example, order lines. Then every order line will have an item like this, like what I have explained last class. So the relation here between the user and order, every user could have multiple orders. So the relation, it will be one to many. Okay, but here the order is every order belongs to one customer, and every order could have multiple lines, and every line belongs to one order, and every item belongs to one order line, but every item could be involved in many order lines. So the relation is like this. So here we have one virtual relation here, one virtual relation which is many to many between the order and item. So we have to draw everything here in our conceptual diagram. Then after that we go to the next step. Next step actually is going to let me clear this first. Now they change everything in the interface, and it looks to me very weird. Okay, so step number 3 is the implementation of the relational data model. So after we create the conceptual or relational data model, then we have to implement it in the database. So the implementation of the relational data model should be written in a style of tables and relations, as you can see here, exactly here. So the customer table is one line like this, salesperson is one line like that, order is like this, order line or item, then we have the item here, and so on. So the implementation is supposed to be like that. Then after this we have to create the physical data storage. So the physical data storage will be the stage of creating the tables and the relationships. So before this we have to convert our relational data model, sorry, the relational data model, we have to change it to what they call it, relational data model. Then after that, this relational data model have to be converted into physical data storage. I'm not going to waste too much time here, because the better way is to get into the system and how we are going to deal with these stages. Then we will learn more than taking a lot of theoretical parts. Okay. After this, we will see the design stages. So the first stage is the initiation. So we have to decide what is the scope of the system and the feasibility, the cost and time estimates for finishing the system. So let us take at first the scope. So for the scope, for example, if let's say we are going to build a point of sale system that should be provided or should be targeting the what they call it, the mini mart, like for example 7-Eleven or KK or whatever mini market. So in this case, we have to decide what is the scope of our system. So the scope is the mini market. Okay. Then after that, we have to decide the functionality. So what is the functionality of the system? The functionality is to do what they call it stock control. This is number one. So we should be able to key in the items or products information into our systems, like product name, price, barcode, so on. Then after that, we should be able to deal with the purchases. So when we purchase, when we order some products to our mini market, then the system should be able to deal with that what they call it, procedure. So our bills or our invoices for our purchases should be easily keyed into our system. Then after that, the quantities of every item should be updated and so on. And also the prices could be updated based on our purchases prices. Then after that, our system should be able to deal with users. So when the user come in front of the counter, they will bring their items. Then the system should be able to deal with the barcode reader to read the product information. Then after that, maybe the employee should be able to key in the quantity of the item and everything, or maybe to deal with the membership. So if we need to deal with the membership cards maybe, or membership numbers, then we have to add that functionality to our system. So based on this information, we are going to decide the scope of the system. So deciding the scope of the system is one of the initial stages that we have to do. Then number two, we have to consider the feasibility of the system. Is it feasible or not? So if it's feasible, then we just go ahead. Otherwise, we should think in different way. Then the other thing, we should think about the cost and the time. So if let's say we are a system developer, for example, then the customer came to us and he asked or she asked to have a system for their mini market maybe, or for their pharmacy or whatever, then we should be able to decide the scope based on the discussion with the customer. And also we should be able to decide what is the feasibility of the system. And after that, we should be able to give the customer a price and time for the system, because the development stage actually is going to take time, right? And also it's going to cost us. So maybe we need to bring some developers, like four people, to do this system or to build this system, and they will take salaries or whatever. Then this is the cost of the system. Maybe if we only do this system or whatever, this depends actually on the business model that we have. So we are not going to discuss this too much, but at least we can tell the customer this system will cost you like 1,000, 2,000, 5,000, whatever. We should be able to estimate the cost and also the time. Then we can tell the customer that after 3 months you can get your system ready, for example. Okay. So all of these estimates are built based on the scope of the system. So the scope is very initial, very essential stage to be done, actually, to decide the cost at the time. After that, we have the requirements analysis. So the user views and needs have to be discussed. So we have to sit with the user and we have to ask them about their needs and what things they need for the system and what views they want and what kind of data they need to key into the system and what kind of reports they need at the end of the day to print or whatever. Also, we have to understand from them the process of data and events, objects, attributes, and whatever. So we have to discuss about everything about the system and the data they require. Then we have the conceptual design. So for the conceptual design, once we came to this point, this is the first stage, actually, first practical stage of dealing with the database design. So here we have to start our modeling. So we have to create the data flow diagrams and also the entity relationships. And after that, we have to draw or model our objects. Then we have to show the user these designs or these models. Then we discuss with the user and see the user feedback. After that, we go to the physical design. So in the physical design stage, the tables will be defined exactly as I mentioned here. So tables will be defined to be ready for the real implementation. And also the application development, query, forms, reports, application integration, and so on, everything need to be designed. Then the data storage and the security, the procedures, and everything. After that, we come to the implementation. The implementation, when we implement the system, we need to do training for the customer and to tell or to teach them how to deal with the system, how to make purchases, how to make sales, and how to deal with the membership, for example, maybe membership renew, membership maybe point collection, maybe what they call it, vouchers or whatever. We have to teach them how to deal with it. Also, we have the data conversion, installation, and everything. Then after that, we go to the stage of the last thing, which is the evaluation and the review. After we implement the things, the system at the user side, then the user should be able to use it for example, for 1 or 2 weeks. Then we should go and ask the user if they have any problem or maybe they have any issue with the system, in order to maybe improve the performance or to improve the design of the interface or to improve the design of the processing or whatever. So this is the life cycle of the design stages of database. Okay, initial steps of design. Number one is to identify the exact goals of the system. So we have to identify the goals based on our scope. And after that, we have to talk with the users to identify the basic forms and reports. We need to know what kind of data forms they need to key in and what kind of reports they want to retrieve from the system. Then number three, we have to identify the data items to be stored. Data that's going to be stored is the data that's needed for the information retrieval. So if the data is not required in reports or it will never be retrieved in the future, then there is no point to save it in the database. Then point number 4 is the design the classes, tables, and relationships. And number 5, identify any business constraints. So if we have any constraint, for example, if let's say for example, if the stock of the item or the product is 3 or less, then we have to show a message to the user to tell the user that we have to purchase a new quantity from this product or this item. maybe for people who want to buy products by credit. So maybe we based on the business constraints, the credit limit is, for example, 100 or 500 or whatever. Then we have to consider all of these business constraints. Okay. Then point number 6, to verify the design matches the business rules. So after we design, we have to check with the user if this design is matching the business rules that they are implementing, and so on. Okay. Okay, is there any question so far?
No.
Clear.
Clear.
Okay, good. What's about the voice? Is it clear?
The voice is clear.
Yeah, clear.
Okay, good. Okay, now we go to the entity relationship model. The entity relationship model is a logical representation of the data for an organization or for a business area. So the entity relationship diagram is actually a logical representation for the data design or for the system design. Then the entity relationship diagram is a graphical representation of an entity relationship model. So we have two things here. We have the ER model and the ER diagram. The ER model is the logic, and the ER diagram is the graphical representation of the logical model. Okay? So later we are going to learn what is this entity relationship model and diagram, and also we will be able to create them when we need. Okay. Now, because now we are in the stage of modeling, we need to know the modeling styles, because for modeling there are some standards. So the standards that we have in this course is two standards. The first one is the chin model, and the second one is the cruise foot model. The cruise foot model. This one is the chin model. Okay. I don't know whether we have any problem here. The voice is very slow. I don't think so, because here I really bought a professional mic for you guys. You see, this one is to improve the voice, and I think this issue is from the Webex itself, because the voice is very high and I'm monitoring the voice is very, very clean. Anyway, this model is the chin model, and this is the way of building the chin model and designing it. And here is the crew foot model and how we use it and how it looks like. So both models here, the chin model and the crow's foot model, are representing the same thing here. So in our slide, we have a patient. So the patient have ID, identification number and first name, last name, address, city, state, ZIB code, home phone, and birth date. So in the first diagram, we can see that we make it like books here, and in the books we have the first item here is the primary key, and the rest of fields are only normal fields. Then here in the second diagram, we have to draw a rectangle for the entity, which is the patient here. Then we have to use awful shapes to represent the fields or data fields of the patient. So here, the one that has a different color here, maybe brown or I don't know what is this color. So this is the primary key, and the others that has the same color here, this is the only or the normal data fields that we have for this patient. So here we have the same exact number of features or what they call it, properties for the patient depends on the model that we have used. So it's up to you. If you want to use this one is okay. If you want to use this one is also okay. But mostly the common one is the crew food model. This is the common one because this one is much easier and much clear. Okay, so let us continue. Okay, here we have what they call it entity relationship model constructs. Okay, let us stay here in this slide. Let us take the crew food model, cruise food model. So how many things, how many components do we have here? The first component we have here is, let me select the tool. The first component is the entity, right? And the second component is the property. The third component is the relation. So this is the three constructs that we have to deal with in our diagrams. So here, entity, attribute, and relationship. Entity is this, the patient. Attribute is the property, which could be the name, could be the address, could be the matric number, could be the phone number, IC, whatever. This is they call it property if we deal with the classes, and it could be named as attribute, especially when we deal with databases. But the both names are referring to the same thing. Then the other thing, the third one, is the relation, which is between the entity and attribute, and also between the entity and other entities. So this is the three constructs that we have. The first one is entity, which could be the person, place, object, event, concept. So it could be a student, could be a teacher, could be a department, could be an what they call it, class, could be subject, could be whatever. Then we have the attribute. Attribute is a property or characteristic of an entity type. So if, let's say, we deal with the person, then we have the person number, person maybe person ID, person name, first name, last name, phone number, address, and so on. If we deal with the place, maybe we for example we deal with the bilik kulliya, for example. So bilik kulliya, we have the room name, we have the capacity of the room, maybe 25 students or 100 students or whatever. Maybe we need to keep track of other information, like it has a data show, it has a whiteboard, it has a blackboard, it has air conditioning, whatever. Okay. Then the other thing is the relation. So the relation is the link between entities, corresponds to the primary key, foreign key, equivalencies in related tables. So if we refer back to our example of the last class, we have the customer who can place the orders. So here we have a relation between the customer and order, and that relation is one-to-many because every customer could place multiple orders. Okay, so this is what they call it, relationship. Then we go to the entity example here. So entity could be a person, could be place, could be object, could be event, or concept. So if person, the example of the person could be a staff, could be student, could be lecturer. The place could be a district, could be town, state, and so on. Then the object could be a building, tool, product, or whatever. Then the event could be registration or application or whatever. Then in the academic systems, it could be adding course or dropping course or deferring study or whatever. Then the concept could be a course or account. Concept, why they call it concept? Because this one has this one is not a physical thing. Okay, that's why they call it concept.
Doctor,
Yes, yes.
I have a question. For the previous slide, what is the primary key and foreign key?
Primary key and foreign key is a future thing that we are going to learn. Okay, don't worry about it now.
Okay, doctor.
Okay, later I will teach you what is the foreign key and what is the primary key. Okay. sample of entity relationship diagram. So here you can see a kind of entity relationship diagram. We can see here the customer. We can see this is the customer. The customer can submit some orders. The relation between customer and orders is one to many, because the customer could submit multiple orders. Then every order requests some products. So the relation here is one to many, many to many, because every order could have multiple products and every product could be involved in many orders. So the relation here is many to many. Infinity here means many. Okay, then also the product used in maybe item, the product could have multiple items or whatever. Then here we have the supplier who could be able to supply the items to us, and supplier could send the shipment to us also, and the shipment includes some items. This is a logical representation of the system. Okay, later we are going actually to learn all about these things. Let me clean. So here, as you can see here, we have the three keys here. Three keys. The first key is the entity. The second key is the relation, and the third key, the entity and the relation here. Only two keys, and the relation has many cardinalities. So the cardinalities means the type of the relation. So if the relation is one to many, for example, like here, this one is one to many, right? So one will be represented like this, and many should be represented like this. Okay, and also we have this small o, and here we could represent this with this one could be like this, only one line or two lines, or this one, the many side, could be like this or could be like this with an o here. So every shape has a meaning. Later I will explain to you what kind of meaning of these shapes. So we have to carefully understand every piece of this. You can see here, this one, this shape is like this, and this shape is like that. So this one has 1, this one has O or 0. Okay, so this one 1 1 mini to 0 mini, something like this. I don't want to go in deep now, because now we are not ready to understand every piece of this notation. Later when we take an example, practical example, then I will be able to explain to you in a very deep detail. Okay, so here for the cardinalities, the double line here means mandatory 1. Mandatory 1. This one, the number 2, it's a mandatory many. So when we have this one line, this line that represents 1, I don't know what happened for the annotation. Okay, this line here means many. sorry, mandatory. This one is here is 1, and this one is optional. This one is mini, and this one is optional. This one is 1, and the other dash is for mandatory. So this is the meaning of the cardinalities. We have to be careful when we deal with them. Okay, let us take this sample of entity relationship diagram. So here in this sample, we have doctor, patient, appointment, insurance company, payment, bill, right? Let us take the entity of the doctor and the entity of the of the patient, and along with the appointment. Okay, so here, if you can see in this diagram, what they use to draw this diagram, they use what they call it here the chin model, right? It's no problem. They can use the chin model. They can use the cruise foot diagram. Okay, so here, if you can see the doctor entity here, they have what they call it physical ID number, or physician ID number. So this is the ID or the card number or the staff number of the doctor. Then we have the first name, last name, address, city, state, ZIP code, home phone, what they call it, page number, primary specialty, and so on. And here, as you can see, the physician ID number is labeled with different color, which is here is the primary key. The primary key is a unique value that cannot be used with other doctors. So every doctor should have different or unique ID number. So the what they call it the primary key is a property or attribute belongs to the entity, and this attribute is not common between multiple entities. So it's supposed to be unique, must be unique. Okay. So here the unique attribute is going to be used as a primary key, and also here the patient has another also entity here. It's another entity which has a primary key, which is the ID number of the patient, because every patient, when you go to the hospital, they give you a certain number to represent yourself. And when you go, every time they will ask you about your name and maybe birthday to find your patient number, to find your record in the system, and so on. So this ID number is supposed to be unique, and it's will not be used with multiple patients. Then they have first name, last name, address, city, state, ZIP code, and so on. So here we have this patient and doctor. Okay, could you tell me what is the relation between the doctor and patient? Anyone can tell me what is the relation type of between the doctor and patient? Is it one-to-one, one-to-many, many-to-many, or what kind of relation?
One to many.
One-to-many.
Yes, one doctor can have many patients.
One doctor could deal with many patients. You
Yes.
want to say like this, right? One to many. So this one is one, and this one is many, right?
Yes.
The true thing is not this. The relation between the patient and doctor is many to many. Why? Because every doctor could deal with multiple patients, and every patient could go to multiple doctors, right? So maybe a certain patient has a problem in the maybe he or she has a cold and flu. Then they have to go to the what they call it the ENT doctor. then for example, they have at the same time they have a kidney problem, then they have to go for the kidney specialist, right? So in this case, one patient could deal with multiple doctors. So the patient is many for the doctor, and the doctor could be many for one patient, right? So the relation here is many to many. Many to many. That's why many to many is not a direct relation between two tables. That's why we have this middle table between the patient and the doctor. So when we have a middle table between two tables, the relation mostly is many to many, mostly, not always. Okay, because there are some special cases where a relation between two tables that have a middle table is not going to be many to many. But for most cases, when we have a middle table between two tables, then the relation between these two tables will be many to many. Okay, the other question here, because if you go back to the last slide, we have something called optional and something called mandatory, right?
Yes.
Yes.
Yes. Yes.
So here, to have a patient in the system, we have to, the first thing, we have to create an appointment for the patient, right?
Yes.
Yeah. Okay, but could we make an appointment for a patient without having any doctor in the system?
Cannot.
Cannot, right? So the first thing that we have to have is the doctor, right? So doctor is mandatory. You see here the dash? Dash means mandatory. And the patient is optional. Because sometimes we have a doctor in our hospital, but no patient for this disease, for the disease which is the specialty of the doctor. So in this case, the doctor may have no patients, right? But the doctor is still there. So the side of the doctor is mandatory and the side of the patient is optional. Okay?
Yes.
Yeah. Okay. This, as I mentioned, this is not a not a direct relation between the two entities. What does it mean? This means that this relation is a logical relation. Let us put it here. This is a logical relation. We shift it up to get the space here. This logical relation, actually, when we have a middle table, like the appointment here, this relation is going to be broken down to two relations. The first relation is this, and the second relation is this. Okay, let us see what is the relation between the appointment and the doctor. How many doctors could be assigned for one appointment? How many doctors?
Many doctors. One doctor.
One doctor for one appointment, right?
Yes.
But one doctor could have multiple appointments, right?
Yes.
Maybe one appointment at 1 o'clock, then the second appointment is 1:30, the third is 2 o'clock, then 2:30, 3 o'clock, 3:30, and so on. So one doctor could have multiple appointments, right? So the relation between doctor and appointment is one to many.
But what I mean is, one doctor can have one appointment at one time.
No. We don't talk about the certain time. At a certain time, they will have only one appointment. This is for sure. But the system could save multiple appointments for the same doctor, right?
Yes, correct.
So appointment at 1
Yes.
o'clock, appointment at 2 o'clock, appointment at 3 o'clock. This is multiple appointments. We are not now considering how many appointments at the time, because this is not our business here. Our business is to know how to save the data into the system. So the appointment should be able to save multiple appointments for the same doctor. Maybe one appointment today, other appointment tomorrow. So it's still multiple appointments, even though if they are in different days or maybe different weeks, different months, it's still multiple appointments for the same doctor. You understand what I mean? But for one appointment, in one appointment, we couldn't have multiple doctors. So the appointment will be only assigned for one doctor to handle one patient, right?
Yes.
Yes. So also the patient is one here and the appointment is multiple, because here one patient could have multiple appointments. So one appointment for to fix maybe teeth, or the other appointment is to go for ENT doctor for cold and flu. So maybe the first appointment is done last month, and the second appointment is this month, and maybe the third appointment is next year, but we still have multiple appointments for one patient. So every patient could have multiple appointments. So the relation here is one to many. Okay. Now, if you can see here, the relation, if you take this relation as a total relation between the doctor and patient here, you can see that the two sides are one to one, right? But this
Yes.
one is not correct. So don't confuse yourself, okay? Even though this side is one and this side is one here, the relation still many to many. The general relation between the patient and the doctor is the many to many relation. Why? Because as I mentioned, the doctor could deal with multiple patients, and the patient could have multiple appointments with multiple doctors, right? So the relation between patient and doctor is many to many, is not one to one as you can see here. Okay, is not one to one. One here is belongs to this partial relation. So the partial relation cardinalities will not going to affect the will not be reflected directly to the general or the total relation between the remote entities. Okay, is this clear?
Yes.
Clear again.
Okay. Any questions so far? This one is very important thing. If you cannot understand this, don't be silent. Ask now, because this is very important and you have to understand this. Otherwise, you will get lost later.
No questions so far. Okay.
Okay, let us see, or come back here to the appointment table. Okay, the appointment table here, you can see that there are two attributes labeled with different color. So this means this different color is to annotate or to mention what is the primary key, right? So here they make the primary key as the date and time, but this is really not correct. Practically, it's not correct. This date and time cannot be the primary key of the appointment, because date and time could be repeated between or among multiple patients. So maybe 2-3 patients, they contact the counter nurses at the same time, and they make their appointments with different doctors. So in this case, we will have the same date and the same time for multiple appointments, and this is not going to be unique, right? And the main important thing for the primary key is to be unique. Okay, so later we will take this example. Actually, later we will dive inside it for in deep details actually, and I will teach you how to decide the primary key and what kind of primary key that we can use. Okay, let us go through the details of this diagram in the slide. As you can see here, there is here doctor is or appointment is scheduled for includes one doctor. Then here the appointment is scheduled by the patient. So here this one is the entity, this one is a relation actually, and here is an attribute. Okay, attribute, it's not easy to write. Okay, so here also we have something called identifier, and the identifier is the primary key or the unique field in the entity table. Okay, so if you don't have any question here, I'm going to move to the next slide. Any question before I move?
No.
Okay. Okay, let us come here and understand what kind of notations we can deal with when we design our entity relationship diagrams. So here we have the basic symbols here. Okay, this one is a basic symbol which is used for entity. The entity could be a patient, could be a doctor, could be an appointment, could be a student, could be class, could be whatever. Then here we have two types of shapes. The first shape is what they call it strong entity, and the other shape for weak entity. Weak entity will have double lines. Okay, the strong entity will have only one line for the border. This one for the weak entity, we have two lines for the border. Then we have something called a relationship model. A relationship also we have a single line and double line. Single line is for relation, and double line is for identifying relationship. Later we are going to explain all of these things. When we need to use them, you will understand why we should use the double or why we should use the single line. And here we have something called, this one is also for relation. Together with this two. So this one actually is a combination of basic symbol and the entity symbol with the relation symbol. Okay, so it will have a rectangle together with the this shape. Okay, so this one is what they call it associative entity. This associative entity is something like the appointment in the previous slide, something similar to the appointment in the previous slide. Okay, then we have something called attribute. So the attribute has three types of shapes. The first type is for the normal attribute. Then the double line circle is for the multi-valued attribute. Then the dotted circle is for the derived or computed attribute. Okay, so this is what we have here. So here we have entities, relations, and associative or relationship, what they call it, a special entity that is also a relationship. So this is a combination between entity and relationship, and also we have something called attributes. 4 things. So the notations are for 4 things only. Okay, this notations we have to always remember. Okay, Why we need to always remember them? Because when we get an example, for example, the previous slide here includes one example, right? Or maybe not this one, maybe this one. This one includes one example. So we have double lined here for one attribute, and here we have dotted attribute. So what is the meaning of this and what is the meaning of this? Based on the notation meaning, we should be able to understand the meaning of these attributes. That's why we always have to keep this diagram in model, in our memory. So we have to remember always the meaning of every shape here, every notation. Okay, let us go to the entity. The first thing is the entity. The entity type versus entity instance. Okay. The entity, as I said in one of the slides here, entity could be a person, could be a place, could be an object, could be an event, could be an concept, or whatever, right? The example of person could be staff, student, lecturer, right? So for example, if let's say we have a staff entity, then in the staff entity we have Ali, Ahmed, Khalid, Mustafa, Amina, and so on. Many people are staff, right? So the staff is type, but Ali, Ahmed, Mustafa, Amina are examples, right? Instances of the type. Okay. So there is difference between the type and the entity instance. So the entity type is the collection of entities, often corresponds to a table. So the type will be reflected into a table, and the table will contain multiple records. For example, if let's say we have one table like this, then this table has ID, name, astaghfirullah. Suppose that this is the table like that, and here we have ID, name, and phone, for example. Okay, so this table is named as contacts, contact table. Okay, and this table is contact, and here inside the contact table we have multiple records, right? So maybe, for example, we have only 2 or 3 records. Maybe the ID for the first one is 1, and for the second one is 2 and 3. Here maybe this one is Ali, and this one is Amina, for example. Amina, and here is Noor, for example. Okay, and they have their phone numbers here saved into the system. So this table actually is a type. This one is an entity type, and this entity type is the contact. Okay, and here for every record here, for example, Ali record is one instance, and Amina record is the second instance, and Noor record is the third instance. So the instance representing a real example of that type. For example, if let's say we have a student table, so the type here is a student, but the instance of the student is the students who are registered in this table. So maybe Ali, Ahmed, Amina, Noor, Mustafa, Khalid, all of these records are representing the instances of the what they call it, the table or the type. Okay. So here for the type, entity type is the collection of entities, but the entity instance is a single occurrence of an entity type, often corresponds to a row in a table. So every row is an instance, and the table itself is the type. Is that clear so far?
Yes, that's there.
Okay. Here we move to the strong and weak entity types. Strong and weak entity types. If you can see here, we have strong and weak, right? So what is the strong and what is the weak? Strong entity type is the entity that exists independently of other entities or of other entity types. Okay, I will give you one example for this. Let us see what is the weak entity type. So the weak entity type is the entity type whose existence depends on some other entity types. So one very clear and common example for this is the city and country. The existence of the city depends on the existence of country, right? So we cannot have Kuala Lumpur without having Malaysia, right? But also we can have Malaysia without having Kuala Lumpur. So maybe we have Malaysia only to represent the 14 states of Malaysia. But we cannot key into the system Kuala Lumpur without key in the country Malaysia, right? So if let's say we want to key in the Kuala Lumpur, we have to go to the table of countries first, and we have to key in the, Malaysia as a row in the country table. Then after that we go to the city table. Then we key in the Kuala Lumpur city based on the Malaysian country. Okay. To do so, here we have to create two tables, right? The first table is like this for the country. So here in this table, they have to have the ID, and here is the country name. So the ID could be number 1 for Malaysia. Okay, and here we have something called, oh, la ilaha illallah. And here we have another table for the city. So the city here, it must have more columns or more attributes than the country, because here they have the city name, but this city name belongs to a country. So we have to mention the country ID here, or everything is lost. I think it's better if I use the paint. Okay, let's use the paint for the rest of our class. So if let's say we have the country here, and as I said, here we have the ID and the name for the countries, countries table, and here we have number 1 for Malaysia, Malaysia. And here we have the table of cities. Cities, another table here. And this table includes the city name, for example, city name, which is, for example, KL. Or here we have to have the city ID, and also we have to have the country ID. So the city ID could be number 1, and the country ID should be belongs to the or the same ID used for Malaysia. So here, this ID is foreign. Here is a primary key. This one is a primary key, and here this one, the country ID, is what they call it, foreign key. Why foreign key? Because this value here, number 1, is coming from another table. So if this value is not available in the other table, then this value is going to be wrong. Okay? So here is the primary key. The primary key cannot be repeated. So it must be unique. So if, let's say, we have another country here, other country should have different number than Malaysia. So maybe here we have Indonesia, and number 3 maybe China, number 4, for example, maybe Singapore, and so on, like that. So if, let's say, we have multiple cities belongs to the same country, so the entry here will be different a little bit, because the country is number 1 here, because we still want to insert another city belongs to Malaysia, right? So Malaysia ID is number 1, and the city ID here we have number 1, so we're supposed to take different number. Maybe we take number 2. So number 2 could be Johor Bahru, maybe GB, right? Like this. Then maybe we want to insert another country, another city belongs to Malaysia also. So city number 3 in the same Malaysia. Okay, so here maybe we have BJ maybe. Okay, so here, as you can see, because this one, the ID of the country is primary key and unique, and here it's used as a foreign key, so it could be repeated. So here, what kind of primary key we should give for every record? As I mentioned, the primary key must be a unique feature, right? So here, if we can see, the city ID and the country ID could be together used as a primary key. Okay, so here we have a composite primary key here, which is including more than one field. Okay, so as you can see here, this combination of these two fields is unique, because here we have 1 1, and we have 1 2, we have 1 3, maybe 1 4, 1 10, 120, 100, whatever. So the one could be, the country ID could be repeated, but with different city ID, which together could form a primary key for this table, for the table of the cities. So here, the existence of any city is based on the existence of a country, right? So this one, this table actually is going to be represented with a shape like this, because this one is a strong type, and the other one here is going to be used with double line shape, like that, because this one is a weak type, and this one is a strong type. Okay, is that clear, guys? Is it clear?
Clear.
Okay, any questions so far?
So foreign key is a mixture between primary key, right? It's a combination, right?
No, the primary key here in the cities table is the combination of two fields, right? The combination of the city ID and the country ID together. This is only to form the primary key for this table. But the country ID here, the value of the country ID actually must come from another table. So in order to key in the value here, the value that we key in here must be available, must exist in the other table. That's why they call it foreign key, because the foreign key will enforce a constraint check. Okay, so if we make this foreign key, then the value here we entered for the city, the country ID in the city table must be existed in the other table. But if we remove the foreign key constraint here, then we can whatever key in here in the country ID, even if the ID of the country is not available in the country table. Okay?
Okay, understand.
Yeah, anyone has a question in this regard? Okay, hopefully not. Hopefully you understand. Maybe I'm afraid that you don't ask questions, but you don't understand also. So if so, it would be a very big issue for you guys later. Okay, let us continue our slides. Here, example of entity type and entity instance. So here we can see that we have a student table. So the entity type is a student, and the entity instances is, for example, here, Farzila, one Haniza, Nur Amin, Nurwani, or Zara Wahida, whatever. So every student is an instance of the type. Okay, so the type is the table itself, and the instance is only a record or one row only. Sorry. Okay. Then here we have naming and defining entities. Actually, for naming and defining entities, we have some tradition. And some custom. So the first thing, we have to use singular noun to use the or to define the entity. So when we draw, for example, a diagram that includes student and includes order, includes maybe customer, so we shouldn't write customers, we shouldn't write students, we shouldn't write orders. So the thing should be something like this. So here we may have customer, only one customer, and here we may have only one order, and here maybe we have one item. So all must be in singular noun. It shouldn't be in a plural. Okay, this is only for the entity relationship diagram. Later, when we design our tables and real relations, the physical one, we should know how to make them in different style or different way, which is more proper. Okay, so for the entity relationship diagram, every entity should have a singular noun, and it should be descriptive and specific. So we cannot use confusing names or unclear names for our entities. So the names should be very clear. So for example, we use purchase order and customer order cannot be named as order. So order only, maybe in the same system we have multiple types of orders. So in this case, it will be very confusing. Okay, so maybe we have a purchasing order and sales order. So here we have to use meaningful names and descriptive names. And also we have to be specific, because purchase order is not the sales order. It's different. It's two different entities. The other thing should be concise. So we have to be very precise and concise. So maybe the name will be, if we have a concept or event, we can say that this type is registration for a student in a class. Maybe we have registration for a workshop, maybe registration for an event. So maybe we have multiple types of registrations. So in this case, we have to be precise and concise. Also, should be named for the result of the event, not the activity or process of the event. For example, an event of a project manager assigning an employee to work on a project. So here, maybe registration for, we can name it as a registration for a project, or maybe registration for a student in a class, or whatever. Or maybe registration for an academic event. Okay? Then here we have the attribute. So the first thing here we talked about the entity. The entity, as I mentioned, is it has these concepts like the entity type and the entity instance. We said that the type is the table and the instance is only the row in the table. And we have strong and weak. I give you the example of the city and the country. So the country is a strong type and the city is a weak type, because the city existence is based on the existence of the country. Okay? So here we come to the attribute. The attribute also we have simple attribute and composite attribute. So the simple attribute is only one field. The composite attribute is multiple, contains multiple attributes. So for example, the full name attribute could contain first name and last name, right? So in this case, the full name actually is going to be considered as a composite attribute. And this composite attribute should be broken down into two components. The first component is the first name and the second component is the second name. Okay? So here we have one concept, which is the simple and composite attribute. Then we have single valued and multi-valued attribute. Single valued and multi-valued attribute. So single valued attribute in each of the attributes has one value only. So for example, if let's say the attribute is the phone number, so inside the phone number field, we have only one phone number. But if let's say we have kind of attribute that contains multiple phone numbers, then in this case, this field is going to be considered as multi-valued attribute, and inside it, we may have multiple phone numbers, and even we may have a fax number or whatever. Okay, so in this case, it would be considered as a multi-valued attribute. Then we have another concept called stored or derived attribute. Stored versus derived attribute. So the stored attribute is data input or set. So normally the stored attribute is data that comes from the user as an entity, as an entry, and that entry is saved directly to the database. So for example, the IC number of a student. So the IC number of the student at the first time is going to be keyed in by the user. So after that, it will be saved into the database. So this is what they call it, stored attribute. But another thing, which is the derived attribute, if let's say we have a birth date of the student saved into the system, so maybe that birth date is 1st of January 2000, for example. Then in one report, we want to show the age of the student. So the age is going to be calculated as the saved birth date, what they call it, here for the age, I will show you here. I will draw it on the screen. So the age here is going to be equal to the current date, which is now. So this field is going to be read from the system. It's not saved into the database, so it's going to be read from the system minus the date of birth. This one is saved into database. So this one is a stored field. Stored field. This every time this notification panel shows up and I cannot remove it. So okay, here the field which is the birth of date is going to be read from the database, and the age here is calculated actually based on that. So here this field is not saved into the database. This one is not saved, but this one is called derived or calculated field. Okay, so this is the difference between the derived and saved field. Okay, is there any question in this regard? After this we have, yes, any question?
No.
Okay, the last thing we have the identifier attribute. The identifier attribute is the identifier of the record. So in every record we must have a unique value or a unique identifier to differentiate between the records. So for example, the identifier could be the matric number for the student table, or could be the staff ID for the staff table, and also could be the car number for the car record, car plate number, I mean, and also it could be order ID for the orders table, could be the product number for the product table, and so on. So the identifier must be a unique field that could be used to differentiate between the attribute, between the instances of the type. Okay, now we are going to take examples about this attribute concepts. So we will take example for the simple and composite attribute. Also, we will take an example for the single valued and multi-valued, and also the stored and derived attributes. And after that, we will go to the identifier attribute. Okay, an example of composite attribute. So here for the address, as you can see here, the address attribute is a composite attribute which includes the street address, the city, the state, and the postal code, right? So here they will use the same shape as you can see here, but if once we have an attribute that's related to other attributes, so definitely and directly we go and understand that this one is a composite attribute that contains all of this. Okay, so this is very easy concept, right? The second example here is all about the multi-valued attribute. So they take the skill example and also the derived attribute, which is the years employed. Okay, here we have an entity called employee, right? And this employee has employee ID, which is the identifier or the primary key of the employee. And after that, we have the employee name and the address, and also the date of employment. So in what date he started this job. Okay, then we have another field called skills. So the skills could be many things, right? Skills could be many things. Could be maybe the employee is able to do web applications, or web application development, or database development, and also maybe knows the C++ programming, and also could know how to use designing tools or modeling tools, statistical tools like SPSS or maybe MATLAB or whatever. All of these are skills, right? So in this field, we have to have multiple entries. So that's why we use the double-lined OFL here. Okay? So multi-valued, an employee can have more than one skill. That's why we put double line. For the derived feature here, we have a derived feature called years of employment. So how many years this employee was in this job. So how to calculate this? How to calculate this is based on the date of employee. Based on the date of employee. So here, years of employee equal to now, which is going to be read from the system, and minus the date employed. Okay, so in this case, the year of employee, is it saved into the database? Definitely no. That's why, because this one is not saved into database, is not retrieved from database. So that's why they use this dotted line circle. Okay, is that clear, guys?
Yes. Yes.
Okay, any questions so far? Any question?
So if it's not stored in the database, where will it be stored?
You mean the years of employee?
Yes, yes. Where it is be
This
stored?
one is calculated whenever we need it.
Oh, okay,
Yeah,
okay.
whenever we need to show this, the system will calculate it immediately and show it to us. It's not going to be saved into the database. That's why it's using the dotted line. In some books they call it derived, and in other books they call it calculated field. Calculated field. So calculated field means not saved into the database, but it's going to be calculated whenever we need it. Okay. The last thing under the attribute, we have the identifier or the key. So the identifier primary key is an attribute or a combination of attributes. If you remember the example of country and city. So in the country, we have something called country ID, which is only one field. But in the city, we make the primary key as a combination of the country ID and the city ID together to be unique, right? So the identifier is an attribute or a combination of attributes that uniquely identifies individual instances of an entity type. Okay, the question here, why we need to use primary key? Anyone could have the answer? Why we need to use, or why we need to have a primary key? Is it necessary?
So the user data does not jumble. What I mean is, it is for one user you have one ID only, not mixed.
Yeah, because other information could be confusing. Yeah, right? Maybe we have a customer. His name is Ali Ahmed, for example, Ali Ahmed, and he came to the counter and he asked. He wanted to have the what they call it, the breakdown of his orders. So if we use his name Ali Ahmed could retrieve wrong user, right? Wrong customer, because we may have multiple customers with the same name, right? Because the
Yes.
name couldn't be unique. So maybe if we key in only Ali Ahmed, maybe we retrieve for him the wrong list of orders. So in this case, the system will not be precise. It will not be concise, right? So that's why we have to have something very unique to differentiate between the entities. So for example, instead of using the name, we maybe create or assign a user number for every user. or maybe we use the IC of the number, the IC of the user as a primary key, as an identifier. So in that case, if the customer came to have the breakdown of his orders, then we ask him about the IC or maybe the phone number, because the phone number is also a unique thing, right? So maybe we ask about the IC, then we key in the IC, we retrieve all orders. So the orders must be correct. Yeah, the orders are going to be correct because we use the very unique identity field. Okay, the composite identifier is an identifier that consists of a composite attributes. So maybe 2, 3 fields or even more. Okay, then the candidate key. The candidate key is an attribute that could be a key, but not yet decided. So maybe for the customer, if I ask you now, what kind of attributes or what kind of identifier we could use as a primary key for the customer? Could you tell me, please? What kind of attributes?
Customer ID or you mean attribute?
Okay. Okay, let us write it. Customer ID.
Yes.
This is one, right?
Yes.
Number 2.
IC number.
IC.
Yes.
IC. What else?
Phone number.
Phone number.
Phone number. Phone number. Okay. What else?
Address.
Other than this?
Email.
Email. Okay, let us stop here. So what we can call this for possibilities? This for fields are the candidates for the primary key. Candidates for the primary key, because until now we did not decide which one is the primary key. We did not decide. So until this time, these 4 fields are candidates. Then we come here and see, is everyone has an email? Maybe no.
Yes.
Maybe no.
All.
Yeah, especially old people. Some of them doesn't have email. So in this case, this cannot be used. Okay, for phone number could be a customer ID. But what if a customer was using the phone number, then after that he terminated that phone number and the company assigned this phone number to different person? Then that person becomes a customer to our system.
Cannot use phone number.
Yes, okay, because this one is a possibility, right?
Yes.
Yeah, so this one is not good fit for our primary key. So here we still have 2 candidates. We have to choose one of them. The customer ID and the IC. So, okay, IC is unique, cannot be changed, and cannot be reassigned to different person. So it's very good to be used as a primary key. Okay, but we have some possibilities, like what if we have a foreigner person as a customer? So they may have different ICs, right? They may have different IC, or maybe they have the IC which is very similar or exactly the same as a local person IC. So in this case, it's another issue, right?
Yes.
Yeah. So what we can do here, so the better thing in this case is to get rid of the IC as well, and we rely on the customer ID, which we generate from the system automatically for every different customer. So maybe this customer ID could be something like 001, for example, 0001, for example, and this one is for the maybe the user customer type, and this one is for the ID, or it could be starting from 1 to infinity as an integer value. So every customer could be 1, 2, 3, 4, 5, and so on. Okay, depends on what you want to do. Okay, so the best choice here is to use the customer ID, and the IC we will keep in the system, we will keep in the table only for supporting information. Okay, it's only for supporting information. So maybe if a customer came and the customer wants the breakdown of his or her orders, then they give us the customer ID, for example 10, and we key in the number 10 and we check your IC number is 1, 2, 3, 4, 5, is it correct? If they said correct, then we print out. Or maybe instead of telling the user or the customer about his IC, we could take his customer ID, for example 10, we key in 10, then after we retrieve the information, we ask about the IC. What is your IC number? Then they say the IC, we compare it with the IC that we have saved in our database to confirm or to verify the personality of the customer. Okay, is that clear?
Okay. But I have one question.
Yes.
Is the composite identifier a foreign key? Does it consider as a foreign key?
No, don't go there. Let us now here talking about the primary key. Later we will come to the foreign key, because the foreign key is different concept.
Okay, sorry.
Yeah, that's fine. Okay. Let us come and see what's the characteristics of the identifier. The characteristics of the identifier, it will not change in value. So if you remember, when we take the phone number as a candidate, the scenario what if the one customer was using a number, then that number was terminated and reassigned by the company to another person who become a customer for our system. So in this case, the value is changed or reassigned to different person. Okay, that's why we excluded that candidate from being used as an identifier, right? So the value shouldn't be changed. The other thing, the value shouldn't be null. So if you remember at the beginning, we started with the email, right? So as I said, what if somebody has no email? If somebody has no email, then the value will become empty, right? It will be null. So null is not acceptable. Value for the identifier. Also, no intelligent identifiers whose structure indicates classification, location, etc. So for example, containing location or people that might change. So for the primary key, we cannot include, for example, the city name, for example, or maybe the address or the phone number, or the things that might change. Okay. Substitute new symbol keys for long composite keys. Okay, if let's say we have a long composite key, we have to find a new symbol key instead of that. So we shouldn't rely on a very long composite keys. Okay, so this is the characteristics of the identifier, and here here we have the simple key attribute. Single key attribute is only one field, as you can see here: student, student ID, student name, other attributes like address, phone number, whatever. Okay, so the student ID is very unique, and it's never going to be reassigned to different student. It will never be reused as well. So only one number is for a certain student, if even if the student is terminated or failed or stopped studying, his ID is never going to be used with different students. So student ID is a good fit for the primary key. Okay, what's about the composite key attribute? So the composite key attribute is something like flight ID. Flight ID. So the flight ID will include the flight number and the date, because the flight number actually is going to be repeated. For example, if the flight this certain flight maybe is departing from Kuala Lumpur to Singapore daily, every day. So this flight ID is going to be used every day, But every day is going to be using the flight number with different date. Okay, that's why the flight ID here is a composite field which includes the flight number and the date. Okay, so here this one flight ID is considered a composite of two subfields or two sub attributes. Okay. Now we will come to the relationship. Okay. Relationship actually has multiple types, and also it has instances. The relationship types versus relationship instances. So the relationship type is modeled as the diamond and lines between entity types, as we explained in the previous slide. So the relationship, it could be line, could be a direct line involving a diamond shape like this. Okay, so this to represent a relation. Okay, between two entities. So the relation supposed to be between two entities. Okay, from here, this line actually, this line is a relation, but this line is not a relation. This is not the relation that we talk about. Okay, so this is not the relation we talk about. We talk about this relation types only between the entities. Okay. Here, a relationship, sorry, we still have some things here. Between entity types, the instance is between specific entity instances. So, okay, here, this relation here, as you can see in this diagram or in this slide, this is a relation between two types, right? But here is a relation instance between instances of the type. So maybe this employee Chen is dealing with the course C++ and Java and also Basic, while this person Milton is taking the course of C++ and COBOL along with the Bill. So here, this is what they call it, instance of relation. Okay. Let us come back here. So relationships can have attributes. So this relationship here, it could have attributes like this, maybe ID, maybe whatever. So in this case, this is what they call it, a special relation, and it will have different way of representation. Okay, so here the relation can have attributes. This describe features of the association between the entities in the relation. So here, if you remember, if you go back to the shapes here, so here is a relation between two entities, right? So here is a relation between two entities. So here, the relation can have attributes. This describe features of the association between the entities in the relation. So here, if you remember, if you go back to the shapes here, so here is a relation between two entities, right? So here is a relation between two entities. So here, if you remember, if you go back to the shapes here, So we have something called a special entity that is also a relationship. So if let's say we have attributes belongs to a relationship, in that case, we may need to use the associative entity notation like this. Okay? Don't worry, guys. Later we are going to face many scenarios and many examples of this, and we will learn everything, inshallah. Don't worry about it. Then here, two entities can have more than one type of relationship between them. So multiple relationship. Between two entities, we could have multiple relationships. Okay? Now I'm not going to give you an example, but later we will face many scenarios. The last point here, the associative entity, which is supposed to be like this, to use this shape. It's a combination of a relation and entity. So the entity is supposed to have, the entity is supposed to have what they call it, attributes here, and the relationship supposed to be linked between two entities. Okay, so this is what they call it, associative entity. And here we see the relationship type and entity relationship instances, as I explained. And here we have the degree of the relation. Degree of the relation is going to be given next week, next class, tomorrow, inshallah. For today is almost more than enough. I think I don't want to confuse you too much. So we still have 1 hour. If you don't have questions or anything to ask about it, let us check if you have any technical problem. Otherwise, we are going to stop our course, our class of today. So please, guys, is there any question?
Sir, can you recap little bit?
Yeah. Let us see if you have any question. Otherwise, I will do a quick recap to summarize the things that we have studied today. Any question?
I think for now I don't have.
Yeah. Don't worry, guys. If you have any confusion or anything you feel like it's you are not confident enough about it, don't worry. If you have any question, just tell me. Just tell me or write it in the WhatsApp group or whatever. Then I will come back to you and answer your question, inshallah, quickly. And the other thing, if let's say you don't have questions in mind and you feel unconfident with the thing, don't worry, because after this we are going to work too many practical scenarios, and we will have also the group work, the teamwork, and we will have the project of this course also. So we will understand everything in deep detail. Don't worry about it. Okay. Quick recap before we finish. So here today we learned the stages of the designing the database. So we have 4 stages. The first thing, we have to conduct multiple interviews or discussions with the customers or with the system users. Then we have to be able to draw the conceptual data model. We have to draw the conceptual data model. So for today, we are still here. Everything we take today is still in the stage number 2, because we are still trying to learn how to draw the conceptual data model. Okay, so we need to understand. Today we learned about the notations, the shapes that we are going to use, and how to draw the relations and what kind of relations we have, and so on. Then next class maybe, or the second class, maybe we will be able to draw the first diagram. So after that, we will give you some examples. Then we do some practice as assignments. Okay. After we do assignments, then everybody could could be able to share the design, then we discuss and what is wrong and what is correct, to share the information between the others. Okay, the third stage is the implementation of the relational data model, and after that it will come to the physical data storage. So as I mentioned, for today we are still in the second stage to learn how to draw the conceptual data model or the entity relationship diagrams. Okay, we discussed all of these design stages. The first stage is the initiation. That includes the scope. We have to decide the scope, what features we have to provide in the system, and what cases we have to deal with, and so on. The feasibility, the cost, time, estimates. Then after that, it goes to the requirements analysis. We have to know or decide what kind of requirements we have. So the requirements could be the data entry forms, could be the reports that's required from the system, and also we have to have what kind of events we have, and what kind of data processing we should take care of, and so on. Then we go to the conceptual design. So in here we have to, after we understand all of these things, we are supposed to be able to draw the models. The models could be data flow diagrams, could be entity relationship, could be objects, and so on. Then after that, after we draw the models, these models are supposed to be given to the user, and we discuss with the user about these models. Then we see, is it correct or not correct? If these models are correct, then okay. Otherwise, if not correct, we take the information, we take the comments about the wrong things, then we go back to our office and we have to correct it. Then we have the physical design and implementation, and after that we have the evaluation and review. So for today we are still here, okay, for the conceptual design. So we discussed the steps of the initial steps of design. Then after that we came to the entity relationship models. As I mentioned, we have entity relationship model and we have entity relationship diagram. The model is the logical representation of the data for an organization. So here is the logical representation, and how to represent this logic is using the entity relationship diagram. So the entity relationship diagram is a graphical representation of the first model, or of the entity relationship model. Okay. Then after that, we came to the modeling styles. We take something about the chin model and the cruise foot model. So we have two types of modeling. We can use whatever. So no problem. If you want to use this, is okay. If you want to use that, also okay. No problem. Then we came to the entity relationship model constructs. So what kind of components do we have in our models? So the first component is the entity, which could be person, place, object, and so on. The second component is the attribute, which is a property or characteristic of an entity. So for example, if the entity is a student, the attribute could be student ID, could be student name, could be address, could be phone number, and so on. The relation actually is the link between entities. So any link between two entities is considered a relation. A relation could be between two entities or more. Could be between two entities or more. Okay, so we could have a relation that involves 4 or 5 tables at the same time. Okay, and every relation could must involve a primary key and foreign key. Primary key and foreign key. Okay, then here we have entity examples. We have sample of entity relationship diagram, because today is all about designing the entity relationship diagrams. After that, we took this sample to show which one could be an entity and which one could be a relation, and also which one could be an identifier. Then after that, we learned about the notations of the entity relationships. We explain how to differentiate between the things. For example, the entity, strong or weak. So we took the example of country and city. So the country is a strong entity and the city is a weak entity because the city is based on the country. So the existence of Kuala Lumpur is based on the existence of Malaysia, right? And also we learned about the relation that has a single line and the relation that has multiple line. Also here we have a combination between the relation and entity, which is called the associative entity, and the associative entity could have properties or could have attributes as well. Then here we have three types of attributes. So the normal attribute and multi-valued attribute. We take the example of skills, and the derived attribute, we take the years of employment here, which is calculated field that's not going to be saved into the database. And after that, we go to the entity explanation about the entity type and the entity instances. We say the entity type is the table, is the collection of entities. So for example, student table is type, but student row is an instance. So maybe in the student type, we have a record for Ali and another record for Mahmoud, another record for Mustafa. So Ali is one instance, Mahmoud is another instance, and Mustafa is another instance of the same type of student, right? Then we have learned about the strong, weak entities. I already explained this. After that, we came to the naming. As I mentioned, the names of entities must be singular noun, should be descriptive, specific, should be concise, should be named for the result of the event, not for the activity or process. And after that, we come to the attribute. So the attribute, we have simple composite attributes, we have single valued, multi-valued attributes, stored, derived attributes, and after that we have the identifier attributes. And we took this example, okay? After that, we came to this to see the derived and multi-valued. We take the identifier keys. So in the identifier key, we understood what is the primary key. So the primary key should be unique, shouldn't be changeable, shouldn't be transferable. And also the primary key could be a single field, a single attribute or composite attribute. Then we came to the candidate key, and we took the example of customer ID, IC number, phone number, and email. Then we started discussing about the email. So we found that some people may not have an email, especially the old people. So that's why it could face a null value. So in this case, we excluded the email. After that, we came to the phone number. The phone number could be transferable in some cases. So that's why we also excluded the phone number. Then we came to the IC. We considered the case of foreigners who could have same exact IC numbers as the local people. So that's why we excluded also the IC, and we kept at the end the primary key, the final primary key that we are going to use for our design, which is the customer ID. And here the characteristics of the identifier will not change, will not be null, and so on. Then here we talk some examples of the simple key attribute, which is student ID, and the composite key attribute, which could be something like the flight ID that includes the flight number and the date. So in this case, the flight ID is the primary key, and it's a composite primary key. Then we came to the relationship types, as we said, and relationship instances. So here in this slide, we can see this is the type of the relationship, and this is the instances of the relationship. Okay, that's all for today. Then we stopped here in the slide of a degree of relations. So I will write some comment. We stopped here. Okay. Hopefully there is no questions. If there is any question, please ask me now before we finish our class. Any question, guys?
So one question.
Yes. Okay.
So does the strong entity,
Mhm.
does the weak entity always depend on the strong entity?
The question again, please.
Does the weak entity always depend on the strong entity?
Yes.
Okay, thank you.
Yeah. This is that clear? If you want any example.
No. I already understand. That's my question.
Yeah, the question is that the weak entity is depends or relies on the strong entity, and the strong entity could be existed without the existence of the weak entity. So we could have Malaysia without having Kuala Lumpur, BJ, and so on. But we cannot have Kuala Lumpur without having the Malaysian country.
Okay. I understand.
Yeah. Okay.
Okay,
Any
thank
other question? Any other question?
you. No.
Okay, so I finished this. Yes. Do you have a question?
No.
No, no.
Okay. Okay, so I'm going to finish this class. Okay, thank you guys, and see you inshallah tomorrow at 12 o'clock. Inshallah. Thank you very much.
Thank you, Dr.